Algebra 2, this is section 4.5, and this entire section is all about looking at graphs and picking apart some pieces of graphs that you are creating. You're going to need a couple different things for this section, the first being a calculator, so get that out. And then here halfway through this section, I'm going to show you a website to go to that will help you to graph these functions. And I think we've talked about it before, but I'll get you there. Okay. So section 4.5, analyzing graphs. The first thing that they talk about is locating a zero. And if you remember from what we've talked about before, let me make this a little bigger. From what we've talked about before, a zero being where it touches the x-axis. So there's a zero here. There's also one located here. They just happen to circle this one to show you. And the location principle says that not always is a zero easy to locate. For example, this zero right here doesn't occur exactly at zero. This one's at 0.3. So it's really, really close to zero, but not quite there. And that occurs at 2.5. So 2.5 on the x-axis and 0.3 on the y-axis. We really want this y-coordinate to be zero. It's not entirely zero in that case, but sometimes it doesn't hit at exact whole numbers. So the location principle says that sometimes you might have decimals there. And the way of determining those decimals or those places where those zeros hit is kind of one good way of doing it is by making a table. So what we're going to do is we're going to plug this equation into our calculator with each one of these numbers in it, and it will help us to find where that zero was located. So I'm going to start with the first, with my equation here. Turn it on. My first number is -2. That's what I'm going to plug in. So I'm going to open my parentheses and -2. Make sure you use the negative symbol and not the minus. -2, and then you're going to use that caret button right here, caret 3, because we're doing it to the third power, okay? -4, parentheses, -2, caret 2. If you need to pause at any point when you're typing this in, go ahead and do that. Practice typing this in at least for one of these numbers so that you can make sure that you get the number correct. So I've typed in my entire equation, and I'm gonna hit enter, and I got -29. So check this one and make sure that you get the same thing, so at least you know that your calculator is working right and you're typing things in correctly. Okay. Now, many of your calculators, I think most of you on your calculators, will be able to use this cheating method, and I talked about this in the last section. You're going to hit this up button and you're going to go back up to your equation. Okay. And then rather than typing the whole thing out again, you're going to replace this 2 with a 1. This -2 with a 1, this -2 with a 1, and that's it. So I've replaced all the -2's with -1's, and that gives me -7, okay? Now, 0, I'm not going to bother typing 0 into my calculator, because if I would plug 0 in here, that would make that 0. Plug 0 in here, that would make that 0. 0 in here, that would make that 0. So all I would be left with is that value of 1, and I think we've talked about that before. So I'm not going to bother typing 0 in. What I'm going to do for the value of 1 is go back up to this equation, and I'm going to hit, I'm going to go to my negative symbol, and I'm going to hit this delete key. So on each one of these, I'm going to hit the delete key. Whoop, nope, don't want to delete my 1. There we go. Delete the negative. There we go. And I have 1 typed in, and that has a value of 1 also. Okay? And I would do that same thing. Go up and type in 2, and type in 3, and type in 4. I already did that, so I'm going to go ahead and give you those values. They are -1, 1, and 13, just to save us a little bit of time. Okay? But practice doing at least one of those, or a couple, just to make sure that you have that correct. Okay? So what we want to do is determine where the 0 is located. Now again, that 0 is located where the y-coordinate is 0, okay? I don't have a y-coordinate 0 at all along here, okay? But what I do know is this number right here is negative and this number right here is positive. So there has to be a 0 living somewhere between there, right? It has to be 0 when it switches from negative to positive. So that means I must have a coordinate something comma 0 that's between -1 and 0. Maybe it's like -1/2 comma 0. That might be a place where it crosses, okay? It's also going to cross right here. There's going to be a 0 that lives between 1 and -1, okay? So that means that it's going to be the coordinate something comma 0, and that coordinate might be like 1.5, okay? And then it's going to hit 0 again when it goes from negative to positive again. And that might be at the point like 2.5 comma 0, okay? So it changes signs 3 different places. It changes from negative to positive, it changes from positive to negative, and negative to positive again. So that means I have 3 places where it's going to hit that x-axis approximately, okay? So let's graph this and see what we've got. Negative 2 is at negative 29, so I'm just going to put a dot down here. We can't really graph that. Negative 1 is at negative 7. 0 is at 1. 1 is at 1. 2 is at negative 1. 3 is at 1 again, and 4 is at 13. So all the way up here. So it's going to be one of these. Like that. Okay. And the zeros that I had talked about, like this would be kind of maybe about 1/2. It might not be quite at 1/2. Maybe it's at 1/4, but I know it's a number between 0 and negative 1. 1 and 1/2 comma 0. Again, it might not be quite 1 and 1/2, but it's going to be close. And then 2 and 1/2 comma 0. Those are the places where it's going to be. Those zeros are going to be located. So just by looking at the table and the graph, we can determine where those zeros are going to be located. They're probably going to be decimals, but that can just help me narrow it down. Okay. So now we're going to talk not about zeros. We're going to talk about maximums and minimums, and we've kind of hit on these before, so I'm going to go through this really fast. A relative minimum is a low point in your graph, and a relative maximum is a high point in your graph. That's basically all they are. Now they're called relative because this isn't the absolute highest point on my graph, right? This graph will continue going up forever, so all of these points will be higher than that one. If it was the absolute highest point on my graph, it would be called the absolute maximum, okay? If this was the absolute lowest point on my graph, which it's not because these go down below it, that would be called the absolute minimum, but it's not. So that's why they're called relative, is because in relationship to everything around it, it's the low point. In relationship to everything around this one, it's the high point, okay? So we're going to do the same thing again for example 2, maximum and minimum points, but we have a little bit of a different equation for this one. These two terms are a little bit different than the one up above there. So I'm going to clear my calculator out, and I'm going to start with negative 2. So parentheses, negative 2. Again, try these first couple ones to make sure that you are doing this or typing these in correctly. Minus 4 times negative 2 to the second power. Minus 2 times negative 2 and plus 3. There we go. Okay. Pause this video if you need to, because I typed that in really quite quickly. So negative 17 was that first number. Okay, I'm going to go ahead and go up and show you negative 1. So I'm going to change all my 2's to 1's, to 1, to 1. Not every calculator will allow you to do this, but I think most of the ones that you guys have will allow you to do that. So that one was at 0. If I plug 0 in again, that gets rid of this term, and this term, because 0 times anything is just 0. So if I just cover those 3 up, 3 will be the number that corresponds to 0. So 0, 3. And I'll give you the rest of these numbers. So I have negative 2, negative 9. These are also in your book. Negative 12. Oh, shoot. Did I miss one? Yeah, negative 5, and I don't know what 5 is. Yeah, it's 5. Let's type in 5. We'll try it. I'll delete and change that 1 to 5, and delete and change that 1 to 5. I forgot to do the number 5. Delete and change that number to 5, and 5 is at 18. Okay, that will help us. All right. Okay, so maximums and minimum points. All right, so let's just graph this and see what we've got going on here, and then it might be easier to determine those maximum and minimum points. Negative 2 is at negative 17. Oh, geez. Hold on. Bear with me here. There we go. Sorry. Did that to me the other day. So negative 2 is at negative 17. I'll wait till it gets non-fuzzy. All right. Here we go. All the way down here at the bottom. Somewhere like that. I don't know. Negative 1 is at 0. 0 is at 3. 1 is at negative 2. I'm plotting these really, really fast. So pause the video if you need to. 2 is at negative 9. 3 is at negative 12. 4 is at negative 5. And 5 is at 18 all the way up here. So we've got this thing going on. Okay, that looks like that. Okay. Now, kind of just to do a mental check, I'm looking at this function right here. X cubed is the highest power, and this is, in fact, what an x cubed function looks like. So I know I graphed him right for the most part. What we're doing is we're looking for maximums and minimums, okay? I see a maximum here and a minimum here, okay? And looking at our table, we can identify that as being, oh, let's see, let's see, okay, so we're looking at a low number here, and then it gets a little bit higher, and then it gets a little bit higher, and then it gets lower again, okay? So here we're going up, here we're going up, here we're going up, and then here we're going down to negative 2. So the place where he switches from going up to down is going to be a place where there's going to be a high point, okay? Because he's going up on one side and then down on the other side, okay? Then he's going down again, then he's going down again. From negative 2, he goes down to negative 9. From negative 9, he goes down to negative 12. But then from negative 12 to negative 5, he's going back up again. So there's going to be a point where he's going to turn around and go back up again. From negative 12, he's going to turn around and go the opposite direction for negative 5. So just kind of looking at the order in which they're going. And then from negative 5 to 18, he's going back up again. So up and up. He's going to turn around 2 different times. Okay, he's going up here, and then he turns around and goes down, and then he's going down, down, and then he turns around and goes back up again. Okay, that's just by looking at those y coordinates. All right, so I'm going to have a high point here and a low point here. It's going to be approximately at like 0, 3, maybe it's at like 1/2, comma 4 maybe instead. But it's going to be at 0, somewhere close to 0, 3. This point right here is going to be somewhere close to 3, negative 12 is where his low point is going to be before he turns around and goes back up again. Okay, so I could graph that on a graphing calculator or on the computer, which is what we're going to do next, to see where those exact points are. But I'll show you that here in just a second. Okay, so pause the video if you need to. I'm going to go on to the next page. All right, so the back page of your handout looks like this. All right, and it says graphing calculators can be used to graph and analyze polynomial functions. So again, we've got a relative maximum that occurs here at this spot, a relative minimum that occurs at this spot. And then they talk about the function increasing and decreasing. And whenever you're talking about increasing and decreasing, you're always going left to right. So they're saying if I'm going from left to right along this graph, left to right, okay? Left to right, I'm marching up along this graph, and this one is increasing, okay? And then I'm still going left to right. This is starting to decrease. So it's decreasing here, and then it starts to increase again. So there's 2 places where he's increasing, here, and there's 1 place where he's decreasing, okay? That is kind of helps me identify a couple things about my graph, especially if we're talking about story problems like we will get down into example 3. But what I'm going to do is I'm going to use a software that I want you guys to become familiar with because it can help you to cheat on this stuff a lot, which is nice. And let's see, I'll have you write that website down, okay? So some of you guys know what or have been here before, but it's www.geogebra.com, okay? And if you just Google GeoGebra is what it's called. It's like geometry and algebra together. If you just Google that, it will take you to the right spot. So I'm gonna go to that website now, and I'm going to show you. I'll just go GeoGebra, GeoGebra, and it will take me here. And I want to click on that first one, dynamic mathematics. Okay, it takes a second to load. Okay, I am going to, and we want GeoGebra graphing calculator. That's what we want. Okay, I'm going to put my document camera over here so you guys can see what I'm doing all at the same time. It takes a second to load. I'm going to go ahead and graph this bottom equation down here. Okay, so this one right here. This x cubed minus 4x squared minus 2x plus 3. I'll show you how to enter that in. Delete. Okay. So I want to click up here in my input, and I want to type in x cubed. So I type in x, and then I do that caret symbol, which is shift, and then the 6 key, okay? And then I do click 3. And if you keep typing, notice how it will type like in that up above in the exponent. I don't want it to do that. So what I'm going to do is I'm going to hit the over key, my arrow key over, and then I'm going to keep typing again. So minus 4x caret 2. I'm going to hit my over key to go back down, minus 2x, and plus 3, okay? It's going to graph my function here for me, okay? And I can zoom in and out if I want to. Looks pretty similar to the one that I graphed. Zoom in over here. Pretty similar to the one that I graphed here. What I'm going to do is I'm going to, there's a function that if I hit this tools button, I can actually hit the extremum. It's all the way on the very right of the basic tools, and I can hit this button and it will give me the maximum and minimum points. So my maximum point is actually at negative, is at negative 0.23 comma 3.24. I said it was going to be somewhere close to 0 comma 3, and then my low point here is at the 2.9 comma 12.05, and I said it was going to be somewhere close to 3 comma negative 12. So this graphing feature is super easy to run. It gets a lot easier the more you do it. Typing those equations in gets a lot easier the more you do it. So use that feature because it can help you cheat and help you get graphs a lot faster. So that's a wonderful tool. All right, let's go back to this guy, do example 3. And I'm also going to graph it on this graphing calculator. I'll show you what it looks like graphed on that graphing calculator here when we're done. So let's see what we're talking about. Annual admissions to movies in the United States can be modeled by the function blah, 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 all that big long junk. It's an x to the 4th power, okay? And if you remember what x to the 4th power looks like, it generally looks like a w, okay? So something of that nature, all right? It's probably going to be shifted over somewhat. We'll see what it looks like on this graph, okay? Since we have all these numbers in here, it's going to look a little bit different than that w, okay? But generally, that's what x to the 4th looks like, where x is the number of years since 2005, okay? So 0 would be the year 2005, okay? 1 would be 2006, 2 would be 2007, and so on and so forth, okay? So the year since 2005 is what those numbers are representing, all right? And the f of x is the annual revenue in billions of dollars, so that's good to note, okay? In billions of dollars. All right, let's just look at the value of 0, and then I'll plug one of these into the calculator, and I'll show you how to, or I'll give you the rest of them. If I would plug 0 into x to the 4th power would make this whole thing 0. This whole thing would be 0. This whole thing would be 0. This whole thing would be 0. And all of that's because 0 times anything will be 0, so all 4 of those terms will be knocked out, and I will have 8.95. So I'm going to put that in. 8.95 is what I have there. Okay, now if we would type in 1, I'll get my calculator out here. All right, and 0.006 times 1 to the 4th power minus 0.0896 times 1 to the 3rd power plus 0.37 times 1 to the 2nd power. Sorry, I have to talk out loud. Minus 0.746 times 1, and then plus 8.95. I'm going to do this all on my calculator at one shot, and I get 8.49. Okay, so 8.49 is that number. Okay, again, you can hit that up arrow and change those numbers out if you want to complete that table. I went ahead and did that for us. So the next number is 8.32. Okay, then 8.11. Then 7.69, these numbers are getting smaller and smaller as we go. 7.02, 6.22, 5.53, 5.36, and then 6.25. It has a little bit of a jump up there at the end. Okay, so let's plot this. Oh man, here we go. Okay. 0 is at 8.95, so right up here. Then 8.49, it's going down. 8.32 down a little bit. 8.11, 7.69. Go ahead and plot these points. I'll be quiet. And then 6.25. It goes up a little bit again. Okay, so our function looks something like this. Okay? All right, something like that. All right, it says describe the turning points in the graph and its end behavior. All right, describe the turning points. So at what point does the graph turn around and go back up? Okay, well, there's a low spot right here at this 5.36. It's going down, and then it jumps and goes back up again. So at approximately at the point 8, 5.36, it has a low point. Okay, it has a low point. And then describe the end behavior. Generally, the graph is going down, but in that last little bit, it jumps up a little bit. So I'm not quite sure with this graph if it's going to continue going up or if it's going to go down. Now, if I have an idea, annual admissions to movies in the United States, typically costs of movies or things like that, typically the price of that goes up. So I'm guessing that maybe this is going to have an upward trend to it after a while, but then again, I don't know how many people go to movies anymore. They just watch Netflix or whatever. So maybe it will continue to go down. I don't know. So let's save that end behavior for when we actually look at the graph. What trend in revenue does the graph suggest? Well, overall, this graph is all of the amounts are going down. So what trend does it suggest? Revenue is decreasing over time. Okay. Besides that last little jump there at the end, revenue is pretty much decreasing. Is it reasonable that the trend will continue indefinitely? Okay, that's something that we kind of have to decide. So will that continue forever and ever and ever and ever and ever? Keep going down and down and down? Well, we know it can't keep going all the way down because at some point we're going to cross 0. And you can't have a negative revenue, right? So it won't be able to continue that same trend indefinitely. No, but it may still decrease. So it won't continue going down forever because we can't have negative revenue here, but it might still continue to decrease. Let's look. I went ahead and graphed this function. I think it's on my other tab here. Yep, here it is. Okay. So, we were wrong. Well, kind of wrong, maybe. This is this dip where it comes down. So we're only looking at this part of the graph here. Ignore all this other stuff over here. We're only looking at this first quadrant. So I'll move them over here like this. We're only looking at that first quadrant. Come on. Well, now I made it now. This first quadrant's all we care about. Okay? So this is what the graph will look like. Okay? So it's kind of going down a little bit, and then it does come back up. So it does not continue to decrease. It actually does turn around and go back up again. Okay. So one thing that let's do this. Let's go back to that handy dandy Extrema tool, and I have to hit my graph in order for it to tell me that. This point is at 7.73. and 5.33. So I'm going to write that down. 7.73 and 5.33. So what this tells me is that x is 7.73 and y is 5.33. Okay, at the low spot. Well, what x is telling me is x is the number of years after the year 2005. So approximately 8 years after 2005, or approximately in 2013 is approximately the lowest point of revenue, and that revenue is 5.33 billion. So 5.33 billion is the lowest revenue that I ever get, and that occurs in 2013. So the end behavior of this graph, to go back and answer this question, is that my graph actually turns around and goes back up. So I would say as As x goes to infinity, y goes to infinity again, if you want to use that end behavior. As my x's get larger, so as I'm moving along the right side of the graph, the y's are going up. Okay, and that is section, what did we just do? 4, 5. There you go.